Hello, thank you for watching this webinar today where we're going to take a quick look at connecting SCOM and ServiceNow and how we go about doing that and kind of what your alternatives are a little bit too. But first, to introduce myself, I'm Bruce Cullen, I'm the Director of Products here at Cookdown, and let's dig in. So, how do we connect SCOM and ServiceNow? Well, there are a few ways. These are all products that are sold individually, but are, better together. So first off, we have Alertsync, which is all about pushing up those SCOM alerts in the form of incident to automate the incident creation process in ServiceNow using your existing SCOM alerts. Then we have Discovery, which is all about populating ServiceNow's CMDB with your existing object data that's stored in SCOM's database and doing service mapping using SCOM's agent network, putting it to use. Then finally we have our ServiceNow Monitoring Management Pack, which is free and lets you monitor ServiceNow from wherever you have SCOM agents. So free lets you see things you wouldn't otherwise see in ServiceNow, which is great. So let's talk about why these products. We're going to look a little bit to set the stage here at a typical journey on the route to kind of ServiceNow Nirvana, what it kind of looks like, and how SCOM can help with that journey. So in the beginning, people typically buy ServiceNow for its incident management capabilities. It's great for that. Usually it starts off with a guy like this, Jim Carrey, or girl, typing incidents manually into ServiceNow, and they're routed to the right place, all manually. It works quite nicely. And you get off the ground, you establish an ITSM process, but then you realize that it would be a much more efficient, you'd be able to get these incidents resolved more quickly and do change management as well, rather than simply incident management if you had a CMDB. When you bring in a CMDB, you can see the context of things like disk failure to understand, great, so a disk has failed, but what disk has failed? What server is it in? Who owns it? Where is it? All that kind of stuff. The contents is what is needed to make this incident truly useful, and that's what a CMDB can provide. Because then we can see what disk it is, what server it's in, and what runs on that server to some extent. So we'll be able to see, good, it's a copy of Windows, whatever version of Windows it is, probably, and the hardware to some extent that it runs on. But we don't know things like the purpose of the server. What does it serve exactly, to know what the impact is on business if it goes down. In other words, we still need more context. And then finally we get to ServiceNow Nirvana, where we go from having more information than simply, okay, this is a disk in a server, to knowing, well, okay, this is a disk in a server that houses a SQL database and a website. It runs in a cluster with another server that looks the same, that services our sales app in our sales facilitation organization. So great, so it's not brought down something really, really important. So we now know what runs on each server and understand the use of each server to know what the impact is of outages, so we can focus on what really matters and know when to actually panic. So that all sounds great, Bruce. Why do we need SCOM in the picture? Well, the answer is it's never actually as simple as that, is it? Looking at the case of CMDB, usually this thing is populated from these four sort of sources. The first off, being the crudest, is good old-fashioned spreadsheets. Ask your IT pros what infrastructure they have, get them to put it in a spreadsheet, import the spreadsheet. Then we have port scanners, which look at all of the ports open on different servers to figure out what they are. And then we have network crawlers, and finally we have custom integrations, and they all play their part. The problem is, in most organizations, you have issues in actually getting these tools to access everything and then keeping it all up to date. So the first thing you might find is a good old-fashioned firewall that separates half of your app off, your business service off, so that a port scanner won't see it, a network crawler will struggle to discover it. Then we have the potential issue of permissions. So in order to discover databases, we need to access the servers on which the database runs. A port scanner won't do that. A network crawler will do that, but only if it has credentials. Custom integrations may or may not do that. They obviously need maintaining, and obviously a spreadsheet isn't going to do that unless it's a static snapshot, in which case it's just going to get out of date. The other problem we have is half-discovered things, where you can get access to some of what is available, but not everything. So half of what is on a web server, a couple of websites, but not everything, not all the app pools, for example. Again, permissions. And then the final one is the issue of spreadsheets. So old, out-of-date data, duplicate entries, badly formed data, broken integrations, all of these sorts of problems. So then what you end up with isn't really that useful. What we've got left here is the manual stuff, so the sales app, business service and application service, some stale database entries and a server and disks which have some use, but it's essentially, because it can't be trusted because it's not complete, it ends up falling by the wayside and not delivering the true value that a CMDB should deliver. So now let's look at how SCOM can help you if you brought SCOM on this same journey. So, and this is where we're going to start introducing the Cookdown products, starting off with Alertsync. So now we can replace Jim Carrey hammering out incidents with SCOM, obviously, and Alertsync. SCOM will raise incidents as stuff goes wrong and they get routed automatically to the right place. Happy days. There's no manual piece. Loads of time is saved. Once you get the rules all in place to route these things, they all go to the right place with the right priorities in ServiceNow. Problem solved. It solves another problem in just generally getting alerts actioned with SCOM. SCOM's primary mechanism for consuming alerts is email, which looks like this in the real world. It's like having a big stack of post-it notes. How do you know which post-it notes to do is the most important? Well, you have to read every single post-it note. And obviously that doesn't scale. If you read a post-it note and go, yes, that is the most important thing, you put it down, there's no reminder that that's the most important thing. Once it's read, it's read. And there's no workflow management system, there are no SLAs. There are many issues in just managing things via email, which is obviously SCOM's primary method for managing alerts. Unlike ServiceNow, which is a full workflow management system, it has SLAs. It can notify you multiple times via multiple methods. It can escalate things. It can communicate the impact of things. It's just designed for this sort of problem much better. So in other words, it will help you as the SCOM administrator get your alerts actioned. So conceptually, how does Alertsync work then? So on the left hand side we have SCOM, and on the right hand side ServiceNow. SCOM raises alerts when stuff goes wrong. These are pushed across to ServiceNow as alert records. These are matched against what are called incident creation rules, which govern when an incident or task now is raised or not. And that's the general gist of it. But obviously the aim of the game is to resolve the incidents and close out the tasks. So these things get updated over time, and this information is passed through the alert record back through to SCOM. So you can see the state of incidents and tasks from within SCOM. And also really useful, you can get the SCOM alerts closed off when the incidents are resolved, or the other way around if you so choose. Really, really useful. Another really important feature of Alertsync is this correlation feature here. So picture this scenario. You have two servers running on top of a hypervisor, running some bits and pieces, all monitored with SCOM. And the hypervisor goes pop. What's SCOM going to do? Well, it's going to light up like a Christmas tree. We're going to get alerts for everything that's being monitored on these servers. Do you want all of these alerts to be raised as incidents? I would be willing to put money on the answer being no. You want to know the server is down, so you do want an incident, but the heartbeat failure or failed to connect to computer alert is probably enough. You don't need the rest of them. So our correlation feature will let you effectively suppress raising all of these things as individual incidents. They're associated with the failure case incident, saving you a whole bunch of incidents to sift through. All right, enough talk. Let's have a look at this in practice. So let's go to a demo. So this is the SCOM console. We're looking at Alertsync here. There are two pieces to the integration. There's a management pack that goes into SCOM and a ServiceNow certified store app. So the UI for the management pack looks like this. You put in some credentials, you put in ServiceNow details, create a connector. This governs what goes up to ServiceNow, and you've got buttons to control various behaviors and a test connection button. So now if I go to internal connectors here, I'll just quickly pull up the subscription on this so you can see how we can choose what gets sent up. So you can pick to send everything from your management group, or pick and choose by SCOM group here. You can pick targets, so if you wanted only a specific management pack, you could pick that here. And criteria as well. So in my demo lab here, I've only sent up incidents where they're in the raise incident state, which is a custom resolution state I created. But you can obviously pick and choose what you want. The next piece of the puzzle is ServiceNow. This is our ServiceNow certified store app. Here we have our creation rules that handle turning SCOM alerts into incidents and tasks. Going through this list, they're sorted in the processing order columns values, with 1 being the highest priority effectively. The first rule here is called a wait rule. It holds back incoming SCOM alerts for a period of time. I've set this one to be a minute, and I've set this one's conditions to match all alerts. You can filter this to say only, whether management pack contains name blah or whatever. And you can and or properties together with these buttons. As far as operators are concerned, you have your standard contains, starts with, is, and more complicated ones like regular expressions and pattern matching. So that's really cool. So this is good for handling flapping alerts, basically, where an alert comes in and closes itself really soon. Then we have our incident creation rules and task creation rules. So mine will go through them in this order, and when a match is found, it stops processing. I'm going to have a look at this bottom one here, which is my fail-safe rule to make sure an incident is always raised. Here I've chosen to raise an incident, but I could pick all the different types of task as well, or problem or incident. We've filled in all the fields we've chosen to fill in. You can see them all on screen. If you have our discovery product, then we automatically map the CI in your CMDB that we'll set. Otherwise, you would set a static CI. And then we have the correlate server down alerts feature, our correlation feature, which is controlled by a single checkbox here. If turned on, then if a server is down, all the rest of the SCOM alerts get associated with the original incident. You can also say here, when a SCOM alert is closed, what do you want the incident to do? Do you want the incident to be resolved or left as is, or what? So you can choose that here as well. If you don't see what you want in the UI to build exactly what rules you want, you always have scripting options like this here. So this checkbox controls the behavior for updating SCOM alerts, for example, and you can see it's a JavaScript. So you can customize this any way you want. Similarly, for creating incidents, you have post-processing here, which lets you do cool things like this. In the previous screen for incident, for example, you will see that we set a static impact and urgency, whereas here we're setting it dynamically based on what comes in from SCOM. And you'll probably want to do this differently for different management packs alerts, and you have the ability to do that here with JavaScript and anything else you want. It's JavaScript after all. So that's really cool. So the next thing to look at is SCOM alerts themselves. So here we go. Here are some SCOM alerts. In this case, I've got a computer that's down. My failed to connect to computer incident has been raised. If I push across this second heartbeat failure one, it should not get a second incident. It should get associated with this original incident, the one ending 152. We're going to give this a minute to be sent across and just have a look at some of the other bits and pieces in here. So you can obviously see the incident information, so who it's assigned to, the incident ID, its state, assignment group, business service, CI, etc. in here. So you can customize in the ServiceNow store app what data is pulled back into SCOM, but this is great for seeing what's actually going on with the incident rather than just the alert. So that's that. Going back now into ServiceNow and looking at the SCOM alerts themselves. While we're waiting for our SCOM alert to come across that we just sent, we'll look at the failed to connect to computer alert that has the incident we're looking to correlate. So you can see all the properties of the SCOM alert, obviously, from the simple ones to the more complicated ones, like down here. We have all of the properties of the monitoring object. This is the thing that raised that caused the alert to be raised in the first place. We have SCOM monitoring configuration here, so from what management pack and what workflow to the management group name. All the properties of that alert are available here, including ones like site name, good for if you're a managed service provider or have gateways. And then finally, where an incident is raised, you will see here the rule that caused it to be raised, and the same is true of task, by the way, and then the incident or task ID. If we open this, we'll see the incident. So here we go. This is my incident here. So we filled in all of the properties from the description to the CI. I'm guessing this is a Windows computer. Let's see. Yes, it is. Windows Server. as you would expect, everything from the rule has been filled in. Okay, here we go. The SCOM alert that we pushed across has been received. It's got no record of incident or task at the moment because it's hit that wait rule. If I go down to the bottom, I missed it. It's gone through the wait rule already from the looks of things. I was too slow. On the history tab, I'll see this though. It hit the wait rule. It waited for a minute before hitting the generic infrastructure rule and being correlated. That correlation is suppressed record creation. So in other words, we have associated it with the same incident. And that's that. Just a quick quote from one of our customers. Alertsync has saved us at least 12 hours of manual effort in incident creation every week and has been an excellent replacement for Avanios. That's from one of our customers, Gift of Hope, from their infrastructure and operations manager, David Young. So moving on now to discovery. This is all about CMDB population. There's a good reason for why we do this with SCOM. I've already started to paint that picture, looking at sort of security and permissions and ports. Ultimately, you want a complete map of your IT estate. Typically, CMDBs look patchy like this. This is actually a phone coverage map of London, 4G I think it was, where the dark blue in my analogy represents CIs that are in your CMDB, and the rest of the not dark blue space is everything else. Well, SCOM, by virtue of monitoring stuff, has objects for all of this, so you can cover large swathes of your IT estate by simply pushing up the data you already have. So the great next question is, good, so what can I actually discover from SCOM? Well, the answer is really straightforward. Anything that SCOM monitors, you can push up into ServiceNow. Anything includes all of these bits and pieces and more. This is just obviously a logo slide of areas where there are management packs in the first place. And then obviously SCOM has agents all over your network that go and collect this data, but we can also use them for service mapping. They have all the permissions they need to do discovery. SCOM's native discovery ability is obviously sort of taken for granted quite often, but it can do all of that stuff because it has permissions already to do it. It can cross firewalls because all the hard work to do that has already been done. So in other words, it has all the access it needs. So the reason to do it using SCOM is that this route will require the fewest extra permissions to do. How does it look? Well, you start by mapping an application, which is saved into SCOM and then pushed to ServiceNow as a service, application, business, technical, whatever type you want. I'm going to give you a really quick overview of all of this with a demo. So we're going to map out an application. We're going to map out the website I'm actually looking at, which is our tool for doing this. So we start off by putting in a component. We're going to look at this server we're on, Infra Web 01. All I know is it's a website and I connect to it. I don't know what's underpinning it. If I select it from SCOM, we prod the SCOM agent and go, hey, what is on you and what do you talk to? So we'll then return a list of bits and pieces. Here we go. I can see from the URL I'm connecting on /ops19, so I'm going to add in that ASP.NET endpoint. By doing so, we'll add in any components that depends on, like app pools and websites. You can see there's other bits and pieces in here, like processes and services that I've chosen not to include, but obviously you can add in what you like. You can see by adding this in, we've dragged on to the map some other bits and pieces, something that looks like another server. If we click this, we'll do the same thing. We'll prod the SCOM agent here. Remember, SCOM has access to all of its agents to find out what's running on it. But this time, we've only filtered in one item because we know that this is talking to this specific service. All the other bits and pieces are here, but filtered out. You can choose to add them in if you want, but we've chosen not to do that by default because we know it's being talked to actively. And you get the idea. We're walking the dependency tree between all of these individual objects. We'll do the same thing here with this presumably SQL machine. It's called SQL 01. Let's see. Yes, it is indeed a SQL box. We can see the specific databases that have been connected to. There's a larger list on here that we filtered out because we know they're not being talked to. But you get the idea. In the case of the application I'm mapping, it actually looks like this, the completed one. We have a web tier, we have two servers in the app tier, and a database server in the back end. So this we will push up into ServiceNow. The result looks like this. So here we have the application service in the middle that I've mapped my SCOM saved app into with all the bits and pieces that make it up. Databases, Windows services, websites, databases, etc, etc, etc. And all of this is pushed up from SCOM. There's one other piece that's required to do this, and that is our discovery management pack, which is the only moving part here. There's nothing in ServiceNow itself. It looks like this, and it works by mapping SCOM classes to ServiceNow classes. And those mappings are held in the JSON format, like this. We map here the MS SQL on Windows database class to the database class in ServiceNow. And we've provided the classes in ServiceNow we're going to populate. Along with the properties we're going to push data into. In the case of name here, you can see one of our are called keys. These represent properties of SCOM objects in this class. We replace these properties with the actual value for all objects of this class. There are two different variants of this map. One is used where an object in SCOM is not inside of an application, and the other one is used where the object is inside of an application. And the only difference being we add in the application in the one where the object is inside of an application and an additional relationship. I don't actually have the time to show you building these from scratch. It's relatively straightforward. There's a wizard in the SCOM tooling here that takes your JSON payload, and then to actually build your JSON payloads, you don't actually have to build most of them. We've already done the hard work, assuming ServiceNow defaults, and we put them on our discovery store. If you haven't got ServiceNow defaults, you can obviously customize these, or there's a tool in ServiceNow itself called the Identification Simulator that will let you build a payload from scratch. It's a ServiceNow tool, and it looks like this. So we're going to build a payload for our database class quickly, just to show you the gist. We're not going to put all our keys in here because we don't have the time. This will just be to illustrate the point. So we pick our discovery source, our class we want to populate, which is going to be database. The first thing you will notice is, great, Bruce, you want to do databases. Databases can't live in isolation. They must be contained by something. And in this case, that is the SQL instance class, which is fair enough. But these also must be contained by something, and here are my options. This is all mined from my CMDB, so if you've changed or customized your CMDB, you'll see your options, not my options, which are ServiceNow defaults. You're then asked to identify the incoming CI as unique. What properties will you use of each class for that? In this case, I'm going to pick the, database and this class name. This tool is meant for doing what ifs. What happens if I push up a database called ops12 or something, db? Will a new CI get created or an additional one get modified? But because this will do anything, we're going to just, we would use our keys, our Cookdown keys here from the SCOM console. Just to drive the product, just to illustrate the point, I'm going to put any old thing in here for a second, just to get it to give me a payload. We can then hit generate script, and there we go. There is our script. This can then be copied and pasted into SCOM, into the wizard. So it would look like this. So then we'd go into SCOM. We would go create discovery. I'm going to disable this question for a second. This is about app mapping. If you enable it, you put in the two payloads, but the simpler case is just pushing up regular, just objects without their apps. It's a shorter wizard, so it's quicker for me to explain. I don't have the time in this call to go through everything. So we're going to find the database class in SCOM and find a database. The thing that is important here is the class that database belongs to. We have all the keys that relates to the database class and anything in the hierarchy below, so database engine, for example. So these are the keys we would copy and paste. We would then be asked for our payload. Here's the one I just built. Obviously, it's not got real keys in it, so I'm going to actually go back to the console. And we're going to copy out our payload here and paste it over the top, and you'll see the keys are in here. You can tell they're valid keys because they're green. If they're black, they're not valid keys. They will get sent up as plain text. So as the words recovery model are here. Once we've validated this is a good valid JSON payload, we will go next and we see what these keys result in for the object we picked. So the correlation key, for example, results in this. The recovery model key results in this. We can obviously see this when we're picking our keys, but this makes it a bit more kind of real. We put in our ServiceNow details and the frequency we want CIs to be discovered at, and then we would hit save and create it. And they could be run as per the schedule or manually. Perfect. So one final thing to show you, which is the power of having all of this data, all the CI data in ServiceNow, and then all of the alert data alongside the incident data in SCOM. This is a squared up dashboard. Squared up are the company we spun out of back in 2019. So you can see the value of all of this data next to each other. You have incident data, you have alert data, but the most valuable thing here is you have data of incidents on the SCOM alerts. They live alongside. With the ServiceNow Monitoring Management Pack, which is our free one, we have information about the experience that you're seeing and users are seeing from each of these locations. Data on the ServiceNow availability. I put here a graph on memory per node. There are 38, I think it is, performance metrics that we pull from ServiceNow instances, and then we have the instances themselves. Really, really useful. Squared Up, if you don't know who they are the company that Cookdown span out of. They are on a mission to make dashboarding simple. They are the single pane of glass across all of your applications from all the different sources you have data in, including things like Azure, but obviously SCOM as well, so that you can have a dashboard for every application, for every team, to see everything from every angle without having to do the good old-fashioned swivel chair monitor between a bunch of wall screens. Really, really powerful. If you like what you see, you can take a trial of it at squaredup.com. And of course, Cookdown Alertsync and Cookdown Discovery, we give trials of all of our products as well. If you like what you see and you want to go deeper and have a fuller demo, we could do that. We can also get you trials of anything, or if you have questions, go to our website. There are question forms there, or email us. So all that's left to say is we're on LinkedIn, Twitter, Facebook, and of course good old-fashioned email if you have any questions on anything or want to connect with us in the future. Thanks very much for watching this webinar.